problem from cycloidal motion of a particle. Okay, and the problem is a particle is projected upwards from the vertex of a vertical cycloid is this is equal to 4a sin psi along the inner smooth surface. So it is given that the surface is smooth, that is smooth cycloid. It comes to rest at the position where the point is s comma pi by 3. This is the intrinsic coordinate s comma psi. Okay, the value of psi is pi by 3. Then the projected velocity is given by 4 options are given. So we try to draw a rough sketch of smooth cycloid like this. Let it be the vertex. Okay, and let this is the tangent at the vertex, and this is the vertical upward direction, this is y-axis, and let it be horizontal, this is x-axis, and let P be any position of the particle where the coordinate is s psi, and we draw a tangent to the cycloid at the point P. Let it meet the positive x-axis at T, and the angle of inclination with positive x-axis by the tangent is psi. And also it is given that the equation is s, this is equal to 4a sin psi. Okay, and now at that point the force act along this is the weight, this is mg, and this is the positive direction of tangent. Okay, and we project the particle from here with initial velocity, we say this is v0. Okay, v0 in the direction of x-axis, since it is initial velocity. Now if we find out the component of force along the tangent, this is given by mg cos, this is pi by 2 minus psi, pi by 2 minus psi, sorry, this is, we write here clearly, mg into cos pi by 2 minus psi. Why cos pi by 2 minus psi? This is a right angle triangle, so it is psi, and this angle is given by pi by 2 minus psi. So the component of mg along the negative direction of tangent is mg cos pi by 2 minus psi. Okay, and clearly this is the normal reaction, it acts along the inward normal, this is positive. Now we write down two equations of motion. We first write down the tangential equation of motion. Tangential equation of motion is given by mv dv ds. This is tangential acceleration, and there is only one force, this is mg cos pi by 2 minus psi. So this is mg cos pi by 2 minus psi, and here must be a negative sign because this is in the direction of negative tangent. Since t, and if we mark this point as k, tk is the positive tangent. Okay, so we get this is minus mg sin psi. Right, now if we find out, or if we first cancel out m from both sides, and then v dv, this is given by minus g into sin psi into ds. Okay, and from here we can write this result as minus g into sin psi into ds. We write ds by d psi into d psi. Then we find out the value of ds d psi. From here we get ds d psi, this is equal to 4a cos psi. By putting the value of ds d psi here, we get the result, this is equal to minus 4ag, this is sin psi cos psi d psi. Okay, and getting the result from here, this is minus 2ag, this is sin 2 psi d psi. And the left side, we can write left side as half into dv square, because dv square means 2v dv. Okay, and if we multiply this half here, we get the result as dv square, this is equal to minus 4ag into sin 2 psi d psi. Now from the given condition, we already let at the initial position, that is the velocity of projection is v0 when psi equal to 0, because for the cycloid at the vertex this is psi equal to 0, and also it is given that the particle becomes at rest at the point where psi equal to pi by 3. So we integrate this result as integration, this is v0 to 0, because at the end point it is rest, so this is dv square, and this is minus 4ag into integration from lower point, this is psi equal to 0 and this is psi equal to pi by 3, it is given, okay, where velocity v equal to 0, and this is sine 2 psi d psi. So we get by integrating, this is given by 2ag, because we get another 2 in the denominator, and this is cos 2 psi, because we get a minus here, okay, extra minus, so minus minus plus, and by putting the range we get psi equal to 0 to pi by 3. So we get 0 minus v0 square, this is 2ag into cos 2 pi by 3 minus cos 0. So get the result 2ag into, this is cos pi by 3, this means minus cos pi by 3, because this is cos of pi minus pi by 3. So this is minus cos pi by 3, and so obviously this is minus of, and this is 1. So we get 2ag into minus 3 by 2. Here minus minus cancel out from both sides, and we get the result v0 square, this is equal to 3ag, and v0 is obviously root 3ag, and this is our answer, that is the initial velocity of projection is root 3ag, and our option is, this is root ag, this is 2 root ag, oh sorry, there will be no option of this type, I think this must be 3ag, okay, and if this is root 3ag, then it must be option number 3. Very interesting problem of smooth surface on cycloid. Okay, thank you for watching.